Okay, and then we are going to start on lesson 4, probability, discrete random variables. Then we'll go over the quiz. So, do you guys want to go over part 1 or do you just want to do part 2?
I thought this one was pretty straightforward. I didn't really have any questions on this.
Yeah, I'm good too. It's pretty simple. Same.
Okay.
Okay.
Okay, so should we just start the quiz as soon as I can try to pull this up? Maybe?
I think that's a good idea.
Yeah.
Then we'll have some extra time to look over lesson 5 because it's pretty long.
Yep.
You guys can't hear that, right? My roommates are going crazy in the other room.
No.
Okay, good.
Nope, you're good. So I guess my only question is, do you guys understand how to calculate the standard deviation from the variance? Did you do that a long problem on that?
Let me take a look.
I think so.
And if you want to start the quiz without me, my computer's just being really slow, and so after our broadcast, I'll probably just take the quiz, and then I'll restart my computer, and then I'll take the quiz. If you guys just want to start and read the questions, I'll just listen and go along with you.
I will be right back. I'm gonna go chew my words and I can't even hear you guys.
Here we go.
All right, I'm back. Do you guys have the quiz? Did you get it, Marie? Did you get it?
Ben, do you have your quiz open yet?
Yeah, I do. I can actually, let me see if I can still share screens. Yep, I can.
Okay, let me.
Okay. So you should be able to like make me the, oh, I'm on a dual screen. Hold on.
Obviously, we can skip the first 2 questions.
I'm going to try sharing an application window instead.
I can share my screen.
Okay, there we go.
Oh, there you go.
So I already have the answers in. I was a little overzealous, but we can discuss anything that anybody doesn't get. So
Okay.
hopefully you can do the first 2 questions on your own. And then we're using the information to answer the next 3 problems. And this is just a table of blood types. So question number 3, the blood types and proportions given in the table above define a probability distribution. So since it all adds up to a perfect number of 1, we know that it is a probability distribution because you've got your 100% in there.
Quick question. If it didn't add up to 1, like it didn't include every blood type, like it just showed O, A, and B, like it didn't have an A, B, but that still existed, wouldn't it still be proportions of a probability distribution?
From what I was understanding from the reading, you know, the whole picture would be a probability distribution, but
so you need everything, every described information. If anything's missing, it's not a correct distribution.
Yes. Because if there's missing info, like say we were missing, for example, type A, and there's 40% of the whole there,
right?
There could be like 6 other types that we don't know about. and they all add up to 40. Or, there could be no types and it just adds up to, what would that be? Like 60? Yeah, a total of 6.6.
Yeah.
So
I just wasn't sure, like, if you had, like, I don't know, something like people's favorite colors, and you had, like, 4 and added up to, like, 99, because it's, like, the majority. And then the rest of it's just, like, a bunch of random colors that no one would ever think of, like teal. Like, if
Yeah.
it didn't include every single possibility, if it was still a distribution. But that makes sense, because you can't really calculate it unless you have everything.
yeah, and I think typically what would happen in that kind of scenario is you'd have like an other column.
Right.
And if their favorite color isn't on the list, then they can just put it as other.
That makes sense. Should we go to question 4? 4, you literally just look at the table and you just pull the answer straight from it.
Yeah, that's most of this quiz, actually.
Oh.
So then we've got question number 5. So 4 is 0.45, obviously. And then question
5, you just
5.
subtract that from 1, and you're good.
Yep. So that's pretty straightforward. And then we've got this little case study for questions number 6 and 7. And it's Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, that's a weird name, demonstrates the identification of the specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. So from that, we've got question 6. If the dogs guess at random, what's the probability they'll correctly identify the dish
1
containing?
divided by 7.
Yep.
0.143.
Yeah. And then question 7 is in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. And the question, the statement we're picking out of here is either it provides strong evidence or little evidence. This one, I wasn't sure if there's a standard procedure on it. I just kind of inferred that it was strong since it was 22 times out of 7 chances.
The strong is what made me kind of question it. It's like it's not as strong.
Yeah.
Like most of the time they actually get it wrong.
Yeah.
Well, not most, but the majority.
Yeah. And when I was looking, the odds of the dog correctly choosing it if there were 7 different.
Right. It's a lot higher than like the odds, but it's still like not that good. That's why I was confused. But
yeah. So I don't know if there's a procedure that I missed somewhere in the reading or something, but I guessed strong, and that was the one they were looking for.
I guess it's just asking, is this statistically accurate? I guess I don't know. Like, does it support it, or does it like disprove it? And it doesn't really do either, but it supports it more than it disproves it.
Yeah, and if it was closer to like a 7th of 54, then I'd say that it was a little evidence.
Right.
Because, no matter how much the chances are, it's never going to line up neatly and be exactly 1/7. But where it's almost half, I think that's stronger rather than little evidence.
Yeah.
So
8, what is the probability of drawing a red? When I see questions like this, I always think it's a trick question, but isn't it just 0.13?
Yep. That's all. That's what I thought when I hit it at first too. I was like, "There's no way it's this easy." But if you reach in, what's the probability of a red-colored candy? It's just the 0.13.
And then green would just be 0.00.
Well, for the green, it's actually 0.16 because they had scribbled out the value and they were looking for us to figure it out. And so I just went ahead and added up all these values and said, okay, what is missing out of 100? and it was 0.16 because this
Got it.
all adds up to 0.84.
I didn't even look at the other numbers.
So then the next question after the green one is, what is the probability that a randomly selected candy is not green? And
What is
that's
that
just the
minus? Or
sum of
minus that?
these. Yep. And then for the final questions, this is pretty much just review. So they've got this chart here. It's ACT scores, admitted into a medium-sized public university. The following summary statistics were calculated, and then it wants to know half of the observations are less than or equal to what number, which we know from previous lessons, the middle point is the median. So it's got to be less than or equal to 24.
So basically this quiz is, can you read a chart?
Yeah, that's the feeling I got. And then top 25%, so the fourth quartile, is going to be above 27 for question 12. And then 13 is just reviewing the rules of probability, and it just wants to know which one is not actually a rule.
It's the
And-
negative one.
Yeah, because in the reading, it tells us that no probability is ever negative. It's between 0 and 1.
Which makes sense.
So even if the probability is like a 0.000000001, it's still a positive number.
Right.
And that's that.
Hey guys,
Yeah.
sorry, the first like 3 minutes of that whole thing, it was like in and out the sound.
Oh, sorry.
Okay.
I was
Not
having
immediate.
problems, but can we just go real quick to
Yeah, you bet.
3, 4, and 5?
Yeah, of course.
So 3 is just asking if the numbers are a probability distribution. It's basically asking, do the numbers add up to 1?
Okay, so that's true.
Yeah.
Okay.
And then 4, you just pull directly from the graph. It says, what's the probability that their type is 0? It's just 0.45.
Okay. Wow. Yeah, that's easy.
Yeah.
And then